First, we will start with a line at the bottom of the paper indicating the floor. Next, we will start with the line on the left side of the paper indicating the back wall of the bin. Now this pile met the back wall, so we're going to start here, create our peak, and then come down to the floor. We'll then draw our three-dimensional part of the pile. Now I'm going to measure the width of the bin, 18 feet. The pile is 18 feet wide. Now I'll measure the distance from the front of the pile to the back of the wall. 16 feet. From the front of the pile to the back is 16 feet. Now I'm going to go up on the top of the pile and measure from the peak to the back of the wall. 6 feet. The distance from the peak to the wall is 6 feet. So first we'll draw our line down the pile. Distance from the peak to back wall is 6 feet. Now in this bin in particular, we actually have a point of reference on the wall. You might be able to see these black lines that kind of go across the bin. That's actually going to be 4 feet tall. So we have a line of reference. So if I climb back to the top of the pile, my line of reference in the pile gets about halfway up to that line of reference. So I've got about 2 feet to the back of the wall. The fertilizer came up the back wall at 2 feet. Now to measure the peak of the pile, as referenced earlier, we have the lines across the bin that are 4 feet tall. And as you can see, the peak of the pile is going to be roughly to that black line all the way across. So your peak's going to be about 4 feet. And the height of our peak was 4 feet. So now we can draw our shapes. We have a rectangle here, a triangle, and a triangle. This will be triangle A, triangle B, and rectangle C.
All right, we have a density scale here. Another part of determining how much fertilizer you have in your bin is determining the density of the fertilizer that you have. Basically, you fill this cup full of fertilizer and you move the weight down the scale to determine how many pounds per cubic foot the density of the fertilizer. Alright, you want to make sure that you get the top of your fertilizer bucket completely flat. Then you're going to slide your scale down your density to get your weight until it balances on this ring. That looks like about 75 pounds per cubic foot.
Now we are ready to solve. We'll start with triangle A. Now we know the full distance is 16 feet, and the distance from the peak to the back wall is 6, so we should have 10 feet remaining for here. So we will take 10 times 4 times 18. And because this is a triangle, we will divide by 2. That is 360. Then we will take that times 75. We now have 27,000 pounds in triangle A of the pile. Now we start
with triangle B. We have the 6 feet, so we know this is 6 feet. So we know this is 6 feet times, now the height of the peak was 4 feet, and we have 2 feet on the back wall, so the height from here to here has to be 2 feet, because it is the difference between 4 minus 2. So we take that times 2 times the width of 18, and because it is a triangle, we will divide that by 2. Come up with 108 times the 75. That brings us to 8,100 pounds in triangle B. Now, for rectangle C, we have 2 feet on the back wall times 6 feet on the base times your 18 feet width. And it is not a triangle, so we will not divide by 2. 216 times 75. That brings us to 16,200 pounds. Now, we will add the pounds. We come up with 51,300 pounds. Now, to put that into tons, we will divide by 2,000, because there are 2,000 pounds in a ton, and we come up with 25.65 tons.